Lesson 2, Factorial Notation and Permutations. So a permutation is an arrangement of objects in an order that matters. So the order in which you put them matters a lot. So for example, when you work in a daycare and you have 6 children in your group, you need to line the group of children up and determine the number of arrangements that 6 children can form while lining up. So if you were to think of this, you have 6 spots. 1, 2, 3, 4, 5, 6. That's 6 different positions, and we have 6 kids. So for our first position, position 1, there's 6 options for children who could go there. So 6 different people could go there. In position 2, there's only 5 children left to choose from because you already used 1 from the first position. So for position 3, there's 4 children. Position 2, there's 3 children. Position 5, there's 2 children, and position 6, there's 1 child left over. So the way that we can write this, that the lineup could be 6 times 5 times 4 times 3 times 2 times 1. So we multiply all these together because each has its own option. And if you do 6 times 5 times 4 times 3 times 2 times 1, you'll get 720. Another way that you can write this into your calculator is using factorials. So 6 times 5 times 4 times 3 times 2 times 1 is the same as 6 factorial. And there's a button on your calculator. On mine, it's second function 4. It's usually a second function, and it looks like this. So you can type that into your calculator to get 720. So we can evaluate factorials because we know that 5 factorial is the same as 5 times 4 times 3 times 2 times 1. You can either type all those things together or use the factorial button on your calculator, and you should get 120. If you do 10 factorial, it's the same as 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. This one's much easier to use the factorial button. You should get 3,628,800. If we wanted to simplify 5 factorial over 3 factorial, we can simplify this without using our calculator at all. So we know that 5 factorial is the same as 5 times 4 times 3 times 2 times 1. And 3 factorial is the same as 3 times 2 times 1. Because we're multiplying, we can cancel things that are the same on the top and the bottom. So because we have a 3 on the top, we can cancel the 3 on the bottom. The 2's cancel, and the 1's cancel. So really, this simplifies to be 5 times 4, which is 20. So you can evaluate that without the use of a calculator. For the next one, we have 12 factorial divided by 9 factorial times 3 factorial. So 12 factorial is the same as 12 times 11 times 10, and because we have a 9 factorial here, I'm going to write times 9 factorial. Because we know it goes 9 times 7 times 8 times 6, all those numbers, but we don't need to write them all out. And on the bottom, we have 9 factorial, and we can write 3 times 2 times 1. So what we can do is cancel out both 9 factorials. Now what we can do is we can simplify the fractions that we already have. So if we take 10 and divide it by 2, this turns into a 5. And if we take 12 and divide it by 3, this turns into a 4. So what we're left with is 4 times 11 times 5. And 4 times 5 is 20, and 20 times 11 is 220. So this is our simplified factorial. Example 4, 8 children are sitting on a bus. There are 2 children at each seat. How many different ways can the 8 children sit? So we have 8 seats, 2 people at each seat. So for the first seat, we have 8 children possible, then 7, then 6, then 5, then 4, then 3, then 2, then 1. So this is a factorial problem, so we would do 8 factorial, and if you type that in, you get 40,320. So there's 40,320 ways that those 8 children can sit on the bus, which seems a lot. So if there's 4 boys and 4 girls sitting on the bus, and each seat must have a girl and a boy, how many ways can they sit? So if we were to think we've got girls and boys, and they are all sitting in some way, there's 4 girls possible here, 4 boys here. 3 girls possible here, 3 boys possible here. 2, 2, 1, 1. It's the same as 4 factorial times 4 factorial. And if you type 4 factorial in, you'll get 24. So it's 24 times 24, which is 576. So that limits our options a lot. Part C, if there's 2 teachers joining on the bus, how many ways can they sit? So now we have to use 5 seats because we have 10 people. So we have 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. So there's 10 factorial ways they can sit, which is 3,628,800. And for part D, how many ways can they sit together if the teachers have to sit on the same seat? So, if the teachers have to sit together, we have 2 of them, so there's 2 and 1. There's only 2 ways those 2 teachers could sit. The rest would be 8, 7, 6, 5, 4, 3, 2, 1. So we have 2 factorial times 8 factorial, which is the same as 2 times 40,320, which is 80,640. So that is how many ways they can sit on the bus.